Hi, my name is Jedidiah, and for my part, going to explain about the application of partial derivatives in business to minimize the cost with the use of Lagrange method. So, this method is used for a company to decide their optimal capital and labor to find out their maximum production or output within budget. Also, this is used to calculate the minimum cost within a range of production numbers required. This kind of case is usually called minimizing cost with output constraints. And now I will be giving you the example of the case. So this is what I got for the case example. If a production of a company that uses two inputs combination is Q equals 3K plus 5L plus KL, and the price for K is $3 and L is $6. So the first question is A. Okay, so the first question is determine the amounts of each units in order to produce 40,777 units. And B is we have to find what is the minimum cost. Okay, let's start with A. Okay, so the first step is we have to determine the optimized function. So the optimized function is 3K plus 5L plus KL equals 14,777. And we have to make it equal to 0. So we minus it all. And this will be used in order for us to make the Lagrange function. And the second step is the constraints. So as we can see, the K is $3 and the L is $6. So the constraint will be 3K plus 6L. And now we make the Lagrange function by using two of these. So it's 3K plus 6L plus lambda 14. Okay, so this is what we got. And for the next step is we have to find the partial derivatives of each variables. So CK, CL, C lambda. And for the CL, it's 6 minus 5 lambda minus lambda K 0. C lambda is 40,777 minus 3K minus 5L minus KL equals 0. And now we use eliminations to find the value of each variable. So Ck equals 3 or we can also write it as lambda equals 3 per 3 plus L. CL is 6 equals lambda 5 plus K times 5 plus K. Or we can also write it down as lambda equal 6 per 5 plus K. Well, it's basically lambda equals lambda. So we can use cross multiplication. So 3 times 5 equals 15 plus 3k equals 18 plus 6l, or 3k over 3 equals 3 plus 6l over 3. And just do this. So k is 3 plus 6l per 3. So this is k, or we can also simplify it to 1 plus 2l. Okay. The next step is we have to substitute the k into the optimized function to find the k and l. Okay, so previously we managed to find k, which is 1 plus 2l. So now we're going to substitute k into the optimized function. 3, 1 plus 2l plus 5l, 1 plus 2l plus 1 plus 2l, l equals 14,777. Now we cross multiply it. 3 plus 6l plus 5l plus l plus 2l squared minus 14,777 equals 0. 3 plus 12l plus 2l squared minus 14,777 equals 0. So from this we know that L1 is 83, L1 is 83, and L2 is minus 89. And since this function is negative, this means that we cannot use this one. So we're going to continue using this one. Okay, so now that we know the L, now we're going to substitute the L into the optimized function in order to find the K. So we're still going to be using the Q function. So 3K plus 5L or 83 plus KL equals 14,777. So 3K plus 415 plus 83K equals 14,277. So it's 86K per 86 equals 14,362 per 86. So K is 14,362 divided by 86. It's 167. So now we know that K is 167. And the L is 83. Okay, so now we can move on to B. So lastly, we have to find the minimum cost. And previously we managed to find the K and L, so we just have to put it inside the function. So it's C equals 3K plus 6L, or 3 times 167 plus 8 times 83 equals 501 plus 498. So the minimum cost is 999. Okay, so I think that's it for my explanation. Thank you for the opportunity and take care.
So I will explain to you guys about marginal cost in derived function application. So what is marginal cost? Marginal cost is additional cost to produce one additional unit product of a certain production level. So you write your additional cost. So if you want to produce more product than already you're targeted, so you must count the marginal cost first. If you want to produce then more than 10 product that you're already targeting, so you must count the marginal cost first. And in mathematically, marginal cost is the first derivative of the total cost function. So we will write the first derivative. So if there is a total cost function or total cost equations and you want to find the marginal cost, you can find the derive of the total cost. So you just one time derive the total cost function and you get the marginal cost. So we can find the marginal cost or MC by the equation of delta TC divided by delta Q, or we can just write like this: MC equal to TC first derivation. So we move to the example of how to find the marginal cost. So this is the example. If the TC is 3Q quadrant plus 5Q minus 25, and we must find the MC, and if the MC are 2 and 5. So we're gonna find the MC first. To find the MC, we can find through deriving the total cost equation first. So we write this, so cost derive first derivative, and the first derivative of the total cost is 6Q plus 5. So we get the MC is 6Q plus 5. And the second question is the MC are 2 and 5. So we can find it by this, we substitute the 2 and 5 into the MC equation. So the MC is, so MC 2, so we can substitute 6 times 2 plus 5, 12 plus 5 equal to 17. And the second one is if the MC are 5, so you can substitute the 2 by the 5, so 6 times 5 plus 5, 30 plus 5 equal to 35. So that's the answer of the question number 1. So we move to the second example. Now C equals to FQ equal to 3Q quadrant plus 10Q plus 50. So C, it means the total cost 2. So we must find the marginal cost, average cost, and the total cost, marginal cost, and the average cost if the Q is 4. So we find the marginal cost first. So the MC equal to first derivative of the total cost. So the first derivative of the C is 6Q plus 10. After that, we move to the average cost. We can find by TC divided by Q. So TC is 3Q quadrat plus 10Q plus 50 divided by Q, and 3Q plus 10 plus 50 per Q. That's the answer of the AC. And we move to the C questions. So if the C when the Q is 4, so we take the equation of the C 3 times, we substitute the Q to the 4 quadrat plus 10 times 4 plus 50. So 3 times 16 plus 40 plus 50. So 48 plus 40 plus 50 equal to 138. And this is the total cost for make 4 products. Then we need 138. So we move to the MC1. The MC1 is 6Q plus 10. So we substitute the 4 to the Q. So 24 plus 10 equal to 34. So if you want to produce the 5th product, so we need to spend 34 costs. And we move to the AC. So we find the AC by the equation of the AC. So we move here to equation 3Q plus 10 plus 50 divided by Q. So 3 divided by 4 plus 10 plus 50 divided by 4. So equal to 12 plus 10 plus 12.5. So equal to 34.5. So the average cost per unit is 34.5. So we move to the exercise of the marginal cost. So there is the question: TC equal to 5Q quadrat plus 10Q minus 20. So we must find the MC, AC, and the total cost, marginal cost, and average cost when the Q is 5. So we find the MC first. MC we can find by the first derivative of the total cost. So first derivative of total cost is 10Q plus 10. And second one is the average cost by TC divided by Q. So equal to 5Q quadrat plus 10Q minus 20 divided by Q, and 5. The total is 5Q plus 10 minus 20 per Q. So this is the equation for the AC. So the third one, the TC when the key is 5. So we make like this. Q is 5. The TC is 5Q quadrat plus 10Q minus 20. So we substitute the 5 into the key. So it's 125 plus 50 minus 20 equal to 155. So the total cost that we need to produce 5 products is 155. The MC1, if the Q is 5, so we move the MC equations. So in here, MC equal to 10Q plus 10. So we move to here, 10Q plus 10. So you substitute the 5 into the key, plus 10 equal to 50 plus 10 is 60. So the cost that we need to produce the fifth product is 60. So the last one is the AC. So we move this equation to this one. So 5Q plus 10 minus 20 divided Q. So 5, we substitute 5 plus 10 minus 20 divided 5. So this is 25 plus 10, 35 minus 20 divided 5 is 4, so it's 31. So the average cost per unit is 31.
Hello everyone, today I will explain you about the elasticity. Elasticity is a function for measure price changes by calculating quantity demand. By learning this, we can predict the price will change. This is the price, and this is quantity. Now I will write the formula. N equal to elasticity Y per elasticity X equal to limit delta X minus 0 equal to delta Y per Y, that's why the bracket, and then per delta X per X equal to demand Y per demand X times X per Y. And I'm going to explain you, this is the first derivative. Now let's do the example. The example is demand function for goods is QD equal to 85 minus 1.5 P quadrat. Identify the elasticity demand when the price is 15. So we write down the QD here is 85 minus 1.5 P quadrat, and then the price is 15, and now I need to find the elasticity demand. So the quantity demand is 85 minus 1.5 P quadrat, and then 85 minus 1.5. The P, we have it, and then we replace the P with 15 quadrat equal 85 minus 1.5 225. I'm sorry. Now 85 minus 337.5. Now we derive it. Demand Q or demand price, it's 1.5. Sorry. And then the next one is move from here to here. The Q or the price is minus 3. 2 times 1 is I'm sorry. Yes, 2 times 1.5 is 3, and then the result is minus 3p. And then elasticity demand is the demand Q, demand price times per Q. And then this is from here minus 3 times 15 from here, and the Q is the Q is like 252.5. So minus 3, B is 15 times 15, 152.5. So it's minus 45 times 6 and 101. The result is minus 2.67. Now let's move on to the next example. The main function for gut is QD equals to 25 minus 3b quadrat. And then right here, QD 25 minus 3b quadrat. QD equal to 25 minus 3b quadrat. And then B per demand price equal to minus 2 times 3, 6. And then per demand price times Q per quantity demand. It's minus 6. B is 5. That's 5 times 5. 25 minus 75. Now 6 times 5 minus 3b times 5. 25 minus 25. Oh, sorry. That's minus 50. Minus 30 times 1, 5. And I will cross it between 30 and 5. It's minus 6, minus 6, and that is minus 6. Okay, now let's do the exercise. Given QD 25 minus 0.5 and the price will be 20. So we need to find the elasticity demand. The equation is the same like the first one. QD equals to 25 minus 0.5. The price is 20. So 25 minus 0.5, it's 400. And then 25 minus 200. And then the result is minus 175. Now derive. It's this Q. That is 0.5. equal to minus 1b. Okay. Now we're gonna find the elasticity demand. Elasticity demand, the Q per the rate times price per quantity. Demand quantity is minus 1 times price 20 60 minus 175. Hmm. 20 minus 4 25, and then the result is 2.28. And this is the elasticity demand from quantity demand and price.
Okay, so today I want to explain about mathematical finance. So mathematical finance is a field of applied mathematics that involves defining problems in finance and providing solutions using methods that draw from probability, statistics, differential equation, optimization, numerical methods, and data science. So just like when we put our money in the bank, the money itself has money values or monetary values. Which can change anytime, and the change can be differ into three types. There is interest, which are the price you pay to borrow money. And then the second one is the inflation. So inflation is the rate of increase in price over a given of time, over a given period of time. And then the last one is the depreciation. So depreciation is the reduction in cost of a fixed asset in sequential order. So depreciation itself can be happen due to wear or tear until the asset become obsolete. Okay, so based on the three types of monetary value, we can calculate the rate of change. Rate of change. The rate of change. So what is the rate of change? So the rate of change is the percentage of value that change over time. So the rate of change is the percentage value that change over time, and it must be on percentage. And there are two types of the changes. There is the simple growth or decay. So simple growth of decay, this means that the change is constant or stay the same. So the formula for this is growth rate in percent ending value per beginning value minus 1. So this is the first rate of change, simple growth, and then the second one is the compound growth. Or decay. So it means that this is compound growth is a constant growth or decay in terms of the rate, and the formula is compound growth is equal with original value per final value minus 1, and the n is number of years. Okay, so here are the exercise for the simple growth or decay. So the question is, if a company's revenue was $100 million in 2020 and grew to $120 million in 2021, how much is the year-over-year growth rate? So the answer is, so the formula for this is growth rate, which are in percent, equal with ending value per beginning value minus with 1. So as you can see here in the question, that the ending value is 120 and the beginning value is 100. So here, and then this comes to 1.2 minus 1. This comes to 0.2. So the growth rate is 0.2 or 20%. So the year-over-year growth rate is, so the year-over-year rate is 20%. That's it.